What we've tried to do really with all our data centers, and Texas DC2 included, is to build a data center not only for today but also for the future, so that the infrastructure that you're putting in place provides you with flexibility and scalability. And there are a lot of different terms that tend to be used to address this. There's wire once and walk away. It's building a lifetime data center, so you're putting infrastructure not just planning for what's going to happen in 3, 4, 5 years, but 20 years. There's going to be changes and you're going to need to make modifications, but the more that you can put things in place to accommodate what's coming in the future and plan for them, the better. And that's everything as simple as when you install your patch panels, put in an adequate amount of wire management so that when that patch panel is full, you don't have cables spilling out of your wire management because it wasn't large enough. It's leaving room in the cable trays. It's understanding that what you're deploying today to support 10 gig connectivity may need to be built upon in the future to get to 40 gig and 100 gig speeds. It's understanding that the power density that comes in today may go up in the future. It's understanding that the airflow considerations or the physical footprint or any of the different things that you need to support in the data center can change over time, and you want to put in infrastructure that can accommodate those changes and can have a very long serviceable life for you. You don't have to constantly go in and tinker with it. The hardware you choose to deploy in your data center can have a big impact on both the load on your physical infrastructure and, in fact, how long that physical infrastructure can meet your needs. A lot of people tend to focus on back-of-house efficiencies, which is all valid and very important, but the decisions you're making around the hardware that you deploy can also have a big impact. It's why we have all that infrastructure. So as you choose systems that are more energy efficient, that can do more processing, if you look at our own UCS hardware that collapse down a lot of that functionality into a smaller number of systems, you can get more out of that back-of-house infrastructure. You, for example, can reduce the amount of cabling that needs to be run to a system. So that not only reduces your costs, but because you've streamlined your cabling, it can actually improve your airflow and give you some energy benefits on that end of it. It also becomes a lot easier to physically manage. Similarly, as you begin to virtualize more, this gives you the option of, I get more functionality relative to the power that's being consumed for that given box. And so that the end result is it provides me with more capacity than I would otherwise have. It's almost a way to get more capacity out of a given space, more usable capacity, rather than having to add a power distribution unit or bring more power in the space. I just put in systems that can provide more functionality and draw less power, and as a result, my entire system can last me for longer than it otherwise would.